Good morning everyone. Today we'll see about the design of T-beam problem. Myself Dr. J. Sagarvan, Professor and Head, Department of Civil Engineering, Rohini College of Engineering and Technology. So let us see what are the given data. First, width of the beam is given by, that is BF is equal to 1200 mm. The depth of the flange, that is DF, is given by 120 mm. Width of the rib is given by 300 mm. The effective depth is 600 mm. The area of tension steel is 8 bars of 25 mm diameter rod is used. The material used in this T-beam section is M20 grade concrete and Fe 415 high yield strength deform bars. First we have to find out the depth of the neutral axis. Since the flange is thin and the area of the steel is large, assume that the neutral axis falls outside the flange of the section. So the section is thin, so first assumption is that neutral axis lies outside the flange, that is dF by xu is greater than 0.43. So using the compactibility relations, compression is equal to tension, that is C1 plus C2 is equal to T1 plus T. So C1 plus C2 is equal to T. Let us assume xu is equal to depth of the neutral axis. So C1 is equal to T1. So we know the value of compression force C1 is equal to, that is 0.36 FCK BW into XU plus C2, that is 0.45 FCK BF minus BW into 0.15 XU plus 0.65 into DF is equal to T, that is 0.87 FY into AST. Substitute the values and find out the XU. So 0.36 into 20, that is characteristic compressive strength FCK, into BW is 300 into XU plus 0.45 into FCK 20, BF is 1200, BW is 300 into 0.15, we have to find out the XU value, plus 0.65 into DF, that is 120, is equal to 0.87 into 450 into area of steel. Already area of steel is given in the problem, pi d square by 4, so that you are getting the value around 4000. So by solving this equation, we will get the value of 240.7 mm. So xu is equal to 240.7 mm. So next we have to find out the xu by d value. So 240 divided by d is for 600, that will be equal to 0.40. Then xu max by d, already we are using Fe 415 steel, so xu max by d is equal to 0.48. Next we have to compare that value xu max, xu and df. So xu max is greater than xu, is greater than df value is 0.4. So also you have to compare df by xu, that is 120 divided by 240.7. So that will be equal to 0.498, that is greater than 0.43. So hence the moment of resistance is expressed as M is equal to 0.36 into xu by d, 1 minus 0.42 into xu by d into FCK into BW into d square plus 0.45 FCK into BF minus BW into YF into d minus 0.5 YF. Substitute all the value, finally we will get a moment of resistance. So how we can find out the YF? We know YF is equal to 0.15 XU plus 0.65 into DF. 0.15 into 240.7 plus 0.65 into 120. So that will be equal to 114.1 mm. So substitute the values one by one. That is 0.36 into XU by D. XU by D already 0.4. Then 1 minus 0.42 into 0.4. Then FCK we know 20 into 300 into 600 square plus 0.45 FCK, that is 20 into BF 1200 minus 300 into YF already we determined 114.1 into D we know 600 minus 0.15 into 114.1. So finally we will get a value of 670.5 into 10 power 6 Newton mm. So you have to write it in a kilonewton meter, 760.5 kilonewton meter. This is a moment of resistance of the given section. Thank you.